Thank you, everybody. It's really nice to be here. My name is Audrey van der Meer. I'm a brain researcher and professor of psychology at the Norwegian University of Science and Technology in Trondheim, where I've been working for the past 30 years. And I'm here to tell you why we remember things better when we write them down by hand. I have been collaborating with my husband for the past 40 years, and in 2015 we started to interest ourselves to study handwriting and what is happening in the brain, because we have these characteristic EEG nets consisting of 256 electrodes that pick up surface activity from the scalp, and we use inverse mathematic models to trace back where the activity in the brain originated, because we're recording from the scalp, but we're really interested in where the brain activity originated. And we've been studying handwriting and brain activity during handwriting with typewriting on a keyboard and brain activity during the typewriting. We have published our results. We have come with recommendations. Basically, it's very good brain stimulation to use your hand to draw or write, because a lot of areas in the brain, the whole brain is basically involved when you write by hand or when you draw, and that is not the case for when you're using a keyboard, because the keyboard only elicits very simple finger movements, whereas when you write or draw by hand, it's actually very intricate movements that are performed. You use your senses much more, and therefore more of the brain is involved. So we have been studying with our electrode nets the pen's potential for learning in the classroom. We have published several studies since 2017 showing that it really is advantageous for the brain. You use your brain to a much larger extent when you're forming letters by hand or when you're drawing. And these publications are open access, so anybody can go and find them online. So what we did in our very first study was to test students, a group of university students, bachelor and master students, while they were drawing words, Pictionary words, so they were presented with Pictionary words such as hedgehog or umbrella, but also more difficult words such as friendship or birthday. And then they had to either draw these words, or they had to give a description of these words by typing on a keyboard, or they had to just type the word repeatedly with one finger on a keyboard. And then we were interested to see differences in brain activity. The 2020 study that has become highly cited, we included a group of 12-year-old children. For the first time, we also asked the participants to write the words by hand, because in the first study we actually didn't look at handwriting, because we assumed that drawing and handwriting, the same underlying mechanisms were active, but we couldn't prove it because we didn't test it. But in the second study, we actually included a handwriting condition and a drawing condition and a typing condition. We found over and over again that when you are drawing or writing by hand, so when you're using your hand to produce forms on paper or on a touchscreen, you use your brain to a much larger extent. The whole of the brain is active. When large parts of the brain are active, the brain is in need of communicating important information between those active parts. And it does that through neural oscillations or brain waves that can occur in synchrony, in red on the graph, or in desynchrony, in blue, and at different frequencies. So what we find is that handwriting and drawing elicits very similar brain patterns, namely synchronized activity in red in the lower frequency bands. And typewriting is the odd one out, because here we find desynchronized activity at the lower frequency bands and synchronized activity at the higher frequency band, where for handwriting and drawing, we find desynchronized activity in the higher frequency bands. And here we see a head model for all the participants, where we subtract brain activity during typewriting from brain activity during handwriting, and then we're left with all these significant areas in red at the lower frequency bands that the brain is more active during handwriting or drawing versus during typewriting. So this is clear and impressive in a way, showing that the brain really is much more active during using the use of a pen. And then more recently, in 2024, we looked at functional brain connectivity to see how the brain was wired up during handwriting and during typewriting again. And then you get like a connectivity matrix showing all the significant couplings in the brain between handwriting and typewriting. And you see in the head model, that model is kind of wearing a party hat during use of a pen, and it's completely flat when they're typewriting. That shows that the brain is, in other words, much more active during handwriting or drawing, during use of a pen. And we see that time and time again, and that forces the brain to be used in a much more efficient way. There's need for cross-communication between those different brain areas, and you use your finger movements, your intricate finger movements, to produce forms on a surface, whereas when you're typing, it's just these simple finger movements that are actually exactly the same for every letter that you're trying to produce. And that's why children who have learned to read and write on a tablet have difficulty differentiating between letters that look similar but are each other's mirror image, for example, simply because they haven't felt with their bodies that the production of a B is actually completely different than the production of a D on paper. So the media has really picked up on this. People all across the world are very engaged in this topic, handwriting versus typewriting, and what it means for the brain. We've been in The Economist, we've had an issue in National Geographic last year, and in Scientific American, so why handwriting still matters in a digital age. And we've also been on Puberty, that went viral with 500,000 likes within a week or so. It's really been crazy. So, what does this mean for the real world? We are not denying that we are living in a digital world, and we're not proposing to go back to writing in stone, but we now know that handwriting is extremely good stimulation for especially maybe the developing brain, but also maybe for the aging brain. We have suggested to the Norwegian government that they should introduce a minimum of handwriting tuition at primary schools, because it's so important for their brains. I'm not saying that it's easy for a 6-year-old boy, active boy, to sit down and to learn to make those letters on paper, but it's very good for their brain, and I would say it's essential for their brain stimulation, to force the brain to be used for what it is good at, and to challenge the brain for what it is good at. And if you want to become good at something, if you want to use your brain to its full potential, you have to challenge it on a regular basis. And you have to sit still and make those letters and produce a good handwriting style. Not only for the brain stimulation, but I also think that handwriting is part of our cultural heritage, and by not teaching the next generation how to write by hand, we're actually losing an important dimension of being human. Thank you.
You mentioned in your talk that you did the study with the participants typing with one finger. Would it be different if they used all their fingers?
That's a very good question, but we couldn't, because if you're using all 10 fingers, then both hemispheres are active, and then it would be a confounding variable, basically. So since we are writing with one hand and using 3 fingers max, we also asked our participants to type with just one finger of their preferred hand, as to not find this crossover effect when you're steering 10 fingers. Also, it's difficult to recruit people who have equal ability of 10 finger typing. So then we would also make it more difficult for ourselves. So we just asked them to use the finger of their preferred hand for typing. But of course, there may be more crosstalk when you're using 10 fingers.
Have you done any study on potentially like handwriting could help old people with Alzheimer? Like today they're forced to use smartphones and they don't really enjoy it, I think.
Yeah, that's also a very nice question. We have been thinking about including or looking at cognitive aging and see whether regular use of handwriting could fend off cognitive decline, so to speak. And we are planning a study where elderly people who are used to keeping a diary on a daily basis or on a regular basis, and compare them with a group of elderly who have gone completely digital and are not using their writing skills regularly anymore, and to see whether we find any differences in brain activity, better brain activity in those who are used to writing. Yes?
You mentioned that handwriting can also help us remember things better. Is that because there is a relation between kind of how active the brain is and how much we remember things later?
Yes, I should have said, these activity we find in all these brain areas on the slide I showed earlier, in a synchronized way at those low frequencies, that kind of brain activity is related to learning and remembering centers in the brain. Yeah.
Thanks for the talk. I was curious about, you mentioned that these kids who didn't write by hand, they had a hard time differentiating between the like the mirrored shapes of letters like B and D. Was that in regards of the handwritten shapes of those letters, or also reading like typed text?
It's both reading and writing, yes.
That is fascinating.
Yeah.
So we actually have a hard time reading if we don't.
And for instance, in Waldorf schools that rely a lot on self-handwritten pensum, they form the letters with their bodies, and they play these games to incorporate the letters in daily life. Because that is the important thing. You need to feel with your body and all of your senses how these forms are shaped.
Thank you.